Hello everyone, I'm Dr. U. Rajlakshmi, Professor of EC Department from Aditya University. Here we are going to discuss the various modules of digital communication. Let us start with the elements of digital communication system. Here in the block diagram you can see the different elements consisting of the source of information. So we are coming to the information. So information can be audio, video, or a data signal that is transmitted into the that we need to modulate and transmit through the digital communication system. That is our intention. So in order to transmit that information, so first we need to convert that analog signal. For example, if it is analog signal, we need to convert it into digital. For that purpose, we are using the source encoder. So what this source encoder will do, it will convert the original input signal into the code format. So here you will get in the form of zeros and ones. Like that, this is one data stream. Now that data stream, so here the source encoder also mainly focus on eliminating the redundancies. For example, if you are having the same data like a repetition, it's redundant, then you can remove that redundant information from by using source encoding techniques. So various types of source encoding techniques like Shannon-Fano coding method, Huffman coding method, all these methods we will discuss in the upcoming modules. Now the output obtained from the source encoder is a binary stream and that will be applied to the channel encoder. For example, during transmission there may be error bits. That error bits must be identified, detected and corrected. That is done with the help of channel encoder. This channel encoder, what it will do, it will add some sort of error bits. Intentionally, it will add some error bits to the data stream. For example, if there are k number of message bits, so you are going to append r number of check bits to the message bits to form a code word. So a code word is a combination of some k number of message bits and r number of check bits. So this is one of the example for block code. So this is one type of block code, which is one type of channel encoding technique. So this is a block code, okay? And now you should know that the output of channel encoder is a code word, group of code words. Those group of code words is again nothing but the binary stream that will be applied to the modulator. So here various types of digital modulators are available. One is amplitude shift keying and another is frequency shift keying technique. And third one is phase shift keying technique. So three different types of modulators, fundamental binary level, or amplitude shift keying technique and frequency shift keying techniques. Okay. And now the modulated signal is applied to the channel. Here channel can be either wired channel or wireless channel. If it is like a wireless channel, so atmosphere acts as a wireless channel whereby the data will be directly fed into atmosphere. In a digital communication system, a number of repeaters are used throughout the channel. So these repeaters will regenerate the original message signal in the form of a data stream. So at the receiver section, our demodulator will collect the noisy modulated signal, and that will be converted into a group of code words by using our demodulator. So again the group of code words is applied to the channel decoder to convert it into the binary stream. That binary stream is again decoded into original message signal or original message format by using our source decoder, and finally the data will be applied to the destination. So these are all the elements of digital communication system. And here you can see the contents like the concept related to the information source. We already discussed that the source can be either analog or digital. The best example, the analog may be either audio, video or data. Similarly, some teletype signal may also be taken. And finally, the source encoder should convert it into zeros and ones. So it converts it into zeros and ones by reducing the redundancy. Here this device performs the data compression. Again, compression can be lossy and lossless. All these concepts we can discuss in the upcoming modules. Next, source encoder, we already discussed that the output of source encoder is a data stream. In order to detect and correct the errors, we use the channel encoder. So this channel encoder adds some check bits to the message bits to form a code word at the receiver so that we can identify the location of error bits. There are different types of channel encoding techniques like block and convolutional coding methods. So these coding methods, by using these coding methods, you can detect and correct the error bits that we will discuss in the upcoming modules. So coming to the digital modulator, the output of channel encoder is a group of code words that will be applied to the digital modulator. This converts it into signal waveforms. Now, finally, the modulated signals, that may be amplitude, frequency, or phase modulated signals, that is applied to that is sent via channel. Here, best example for wireless channel is atmosphere. And wide channel can be the traditional telephony, optical fibers, or underwater acoustic channels. These are all the examples of wired channels. So different types of noise performance will also be considered for evaluation. And similarly, here you can see the received data is collected by the demodulator, and this demodulator takes the noisy modulated signal and converts it into a group of code words. So this is the opposite functionality done at the receiver section. So group of code words are again converted into original sequence binary stream with the help of channel decoder. So channel decoder has opposite functionality as channel encoder, and to attain accurate binary stream, here the channel decoder should have an idea of the type of the code used in the channel encoder and the redundancy contents in the received bits. And finally, the data, that is a binary stream, is converted into the original message signal format by using source decoder. Here, this source decoder has opposite functionality as that of source encoder. So this is an approximate replica of original message signal, and this data will be collected at the transducer. And here we should know that the performance of the system, the digital system, completely depends on the bit error rate, signal to noise ratio. Here bit error rate is nothing but the number of error bits per second. And signal to noise ratio, it should be as good as possible. And the measure of decoder reconstruction. So how the demodulator can be able to reconstruct the original signal. So all these parameters will affect the system. So they should be as better as possible for the best digital communication system. So this is all about the elements of digital communication system. And with this we can wind up. And next we can continue in the next module. We can continue with the advantages of digital communication system. Okay, we can continue in the next module. Thank you all.